Hello. Okay. The earlier lecture has been finished. Okay. Uh, so, in our last lecture, we were discussing about the network layer, isn't it? And we'll continue with the MAC layer. And in that, we'll be discussing about CSMA, that is Carrier Sense Multiple Access. Okay. So, you have already learned you have already learned the various MAC protocols, that is Aloha, slotted Aloha, etc. Okay, and today we will see the CSMA, that is Carrier Sense Multiple Access Protocol. Let me first share the screen. Wherever you find any difficulty, you can ask me. Hope the screen is visible to you all. Hello, is the screen visible to you all?
Yes, ma'am.
Okay, fine. Fine. So, what do you mean by carrier sense, first of all? Carrier means the channel through which the data is exchanged or data is passed. Okay. So, carrier sense, sensing the carrier means what? We are listening to the carrier. Is the carrier free or is the channel free for the data transmission, or it is not free? Okay. That is nothing but carrier sense. Okay. Then multiple access. Multiple access means what? There are number of stations. For example, here you can see that there are number of stations which are connected through a common shared channel. So this is a shared channel, and all these hosts which are connected to this channel, all of them are having the same priority. Okay, no one is in superior than the other, and so on. All of them are having the same priority. So carrier sense multiple access. So in the Aloha as well as slotted Aloha, what we have learned, as soon as the packet is, as soon as the frame is ready with a particular station, it just starts transmitting, irrespective of whether the channel is free or not. Okay. Whereas by doing so, the collision would be more in case of Aloha as well as slotted Aloha. Whereas in case of carrier sense multiple access, before actually the data transmission is carried out, first the channel is sensed, or first the channel is listened. And if the channel is free or if the channel is idle, then only the data transmission or the frame would be transmitted through the channel. Okay. So usually this CSMA is used for the LAN, that is local area network, as the propagation time in this local area network is very small, and hence the CSMA, what are the variation of or the different CSMA which are there, that we'll be studying as we go further, and that those are typically used for the local area networks. Fine. So if a frame has to be sent by any station, the first thing what it will do is it would sense the channel. In case if the channel is free or if the media is free, then the data transmission would be carried out. Okay. But what happens sometimes due to the propagation delay? So say suppose A is transmitting certain frame, and till that particular frame, the first bit of that particular frame reaches to the other end. Okay. What Z would assume that there will, because it takes certain time to reach from the station A to station Z. So it takes certain time, isn't it? So what Z would assume, that there is no packet, or the media is free, because still that particular frame has not reached towards Z. So what it can do is it can also start transmitting. Do you agree to this, all of you? Due to the propagation delay, the channel, if a frame is sent, or if a frame, the station A has propagated or it has transmitted a frame till it reaches to Z, Z would find that the channel is free, because A would only send the frame when the channel is free. Fine. And Z, what it will do, it will make out that the channel is free, and it may start transmitting the frame by this station Z. So somewhere in between there would be a collision. Do you agree to this, all of you? Okay. So in case if the propagation time is more, there is more chances of the collision. Whereas if the propagation time is short, if it is less, then the chances of collision would also be reduced. Okay. Now you can see that what should be the what is the vulnerable time? What do you mean by vulnerable time? It is a time for any particular packet, or for any particular frame to get collided. Are you getting me? Okay. What do you mean by vulnerable time? It is a time in which there is a possibility of collision. So say suppose if this time so the time which by the station A takes to transmit the entire frame, if that entire frame is means it takes around propagation time, that means that the first bit has already been reached here. It means that there would not be collision, because D will find that the first bit has reached. Okay. And it would make out that there is some traffic in this transmission media, and hence the vulnerable time, that is a possibility of collision, is equal to the vulnerable time is equal to the propagation time. Hope this is clear. Or shall I repeat this once again? What do you mean by vulnerable time? It is a time in which there is a possibility of collision. Vulnerable time is nothing but the time which for the possibility of collision. Okay. So if say suppose this is equal to propagation time, that means the entire the frame has reached, the first bit of that frame has reached to this the other end of this particular channel or particular LAN, isn't it? So that means now once it has been reached, it implies that there is some frame which is lying here, and there would not be any collision. Okay. So the possibility of collision would be there in this vulnerable time. So, and if it is equal to the propagation time, that means the possibility of the collision would be 0. Is this thing clear, everyone? Hello? Okay. So the longer the propagation delay, so you can see that if the propagation time is more, the chances of collision would also be more, and hence the performance would be reduced, or the performance is the worst of this protocol. Now there are certain variations of the CSMA. So we'll see one by one. The very first one is known as a one persistent CSMA. Okay. So in case of one persistent CSMA, what happens? Any station, if it wants to transmit a frame over the LAN, it continuously senses this channel. So you can see that this is the channel. It continuously, any station, say suppose station A wants to transmit a frame through this channel, it continuously senses this channel. So when it finds that the channel is busy, it would not start transmitting the frame. Do you agree to that? That is what we have learned about CSMA. Okay. So if the channel is busy, there is no point in transmitting the frame, because there would be a collision. So continuously it would sense the channel. As soon as it finds that the channel is free, okay, then what it will do, it will start transmitting the frame which is there at station A. Okay. So you can see that to avoid idle channel time, we are using this one persistent protocol. We'll see as we are going. If the medium is idle, if the channel is idle, nothing to do, just transmit the frame immediately. Whereas if the channel is busy, if there is some frame which is there onto the channel, then what it has to do, then it transmits it immediately with the probability 1. That means it is sure that as soon as the channel becomes idle, it starts transmitting the frame by the station A. But the thing is that if in case some other station, say station B, is also sensing the channel at the same time, it would also find that the channel is busy till here. Okay. And as soon as the channel becomes idle, both A as well as station B, both of them would start transmitting the channel, transmitting the frame. Okay. And if both of them starts transmitting the frame, then there would be a collision. Are you getting this? Hello? Okay. So if more than one station wants to transmit a certain frame through the channel, both of them are continuously sensing the channel. In case if the channel is busy, both of them are waiting till the channel becomes idle. And as soon as the channel becomes idle, if more than one stations are there, both of them starts transmitting through that channel. And since more than one station is transmitting through the channel, there would be a possibility of collision, isn't it? So here, in case of one persistent, what the stations are selfish. That means as soon as the channel becomes free, they want every station wants to access that channel, isn't it? So they are selfish. And if two or more station becomes ready at the same time, the collision is guaranteed. So it is sure that the collision would be there. So this is about one persistent CSMA. Now there is somewhat variation to this that is known as a non-persistent CSMA. So in case of non-persistent CSMA, is if a station has a certain frame to transmit, first it senses the channel. Okay. If it finds the channel is idle, nothing to do, just starts transmitting. Whereas if the channel is busy, with certain frame in its channel, what it will do? It will wait. It would not continuously check the channel as in case of this one persistent CSMA. What it will do? It will wait for some random amount of time. Once again, it will sense the channel. Again, if the channel is busy, again it will wait some random amount of time. Again, it will sense the channel and so on. Are you getting me? Hello? Instead of continuously sensing the channel, it waits for a random amount of time. Okay. And once again, it would sense the channel. So if say suppose station A wants to send certain frames, station B is also wanting to transmit certain frame. Initially, both of them are finding that the channel is busy. Okay. So station A waits some random amount of time. Say suppose it waits for 5 milliseconds. Station B also finds that the channel is busy. It may wait for some other, it may wait for say suppose 8 milliseconds. Okay. And once again, it will check whether the channel is free. Fine. After 5 milliseconds, station A would check whether the channel is free. If the channel is free, it would start transmitting. Meanwhile, again at 8 milliseconds, again station B would check whether the channel is free. If the channel is free, it may start sending the frame. And if the channel is not free, it would again wait for certain random amount of time. And once again, it would it would listen to the channel. This is how the non-persistent CSMA would work. Have you understood this? So here you can see that since the waiting period is random, means they are picking some random amount of time to wait. So there is the possibility of collision is now reduced. Whereas in case of one persistent CSMA, what you have observed that since continuously both these channels are sensing this channel and both of the stations wants to transmit the frame. So as soon as the channel becomes idle, both of them starts transmitting. Whereas here it is not so. It is not continuously sensing the channel. It waits for a random period of time provided the channel is busy. As soon as the channel becomes free, at the end of this waiting time, it would check whether the channel is free. And if it is free, it starts transmitting through the channel, or else it would again wait for certain period of time. Hope this is clear, everyone. Okay. So the problem with this is that some of the bandwidth or some time would be wasted. For example, here it takes around 5 milliseconds as a random period, and here it may take 8 milliseconds. Assume that at time t equal to 3 milliseconds, the channel has become now free. But what the station A would, when the station A would sense after 5 milliseconds, after this again 5 milliseconds, it would sense. So from 3 millisecond to 5 milliseconds, so this 2 millisecond time would be wasted because the channel is idle here. Even if it is idle, none of these stations, even if they are having their frames ready to transmit, they are not transmitting at this particular period of time. Okay, so this time the channel is wasted here. Okay, or the bandwidth is wasted, or you can say the time is wasted of the channel. Hope this is clear, everyone. Okay, so a station with frames to be sent should sense the medium. If the medium is idle, nothing to do, transmit, or else it has to go to step 2. If the medium is busy, back off or wait a random amount of time, and then again, once again, it has to check whether the channel is free or not. Fine. How about the performance? So since we are using the random delays here, okay, the probability of collision would be reduced now. Okay, because both these stations would have different waiting time, but the wastage of there would be a wastage of bandwidth, because sometime it might be possible that there would be the channel would be idle and no stations would be using this channel. Is this thing clear, everyone? Hello. So this was about non-persistent CSMA. Whereas the third type of CSMA is P-persistent. It is very much similar to that of one persistent CSMA. But here it is used for the slotted time. So you might have studied about slotted aloha, because the time period would be divided into some equal spaced slots. Okay. Time is divided into slots where each time unit typically equals the maximum propagation delay. So each time unit of this slot would be the maximum propagation delay, TP. Okay. Now here, in this case, in one persistent CSMA, as soon as the channel becomes free, both the stations would start transmitting. Whereas here, in case of P-persistent CSMA, in case if the channel is idle, if the medium is idle, it either it transmits with the probability P. In case of one persistent CSMA, that is nothing but 100% both the stations would start transmitting. Whereas in case of P-persistent CSMA, with the probability P, either the station would transmit, or it would differ, or it would wait for certain period of time. Wait one time unit, and it would differ by 1 minus P. That means Q is equal to 1 minus P. Okay. Either with the probability P, it starts transmitting, even if the channel is free, or it would wait till the next slot with the probability Q. And then again, it would start with this. Okay. So here also, continuously it would listen the channel. As soon as the channel becomes free, either it with the probability, either it starts transmitting, or it will differ for the next time slot. Again, at this slot, with the probability P, it may transmit, or it may again wait for the next time slot, and so on. Okay. So this is how the P persistent CSMA would work. Is this thing clear, everyone? In case of one persistent, as soon as the channel becomes free, both the stations would use this channel and starts transmitting. Whereas in this case, in case of P persistent CSMA, with the probability P, either it may transmit, or it may wait for the next time slot with the probability Q. Q is equal to 1 minus P. Okay. And again, here also, when it comes, it would check whether the channel is free. If the channel is free, again the same procedure would be carried out. Any doubts in this? Okay, so by using this P persistent CSMA, it reduces the possibility of collisions. Like here it should be one non-persistent should be here, and one persistent should be here. Okay, so in case of this it reduces the possibility of collisions like one persistent CSMA. In the one persistent CSMA, we knew that as soon as the channel becomes idle, the collision, the chances of collision would be more, isn't it? Whereas in case of non-persistent CSMA, what we have studied is that there would be some idle period, and the performance would be reduced for in that case. So in case of non-persistent CSMA, it reduces channel idle time, isn't it? Like non-persistent CSMA. Whereas to overcome these two problems, we are using this P persistent CSMA. Hope everyone is clear with this one persistent, P persistent, as well as non-persistent CSMA. Any doubts if you are having, let me. This one, you mean to say, okay. See, this is same as that of one persistent CSMA. Continuously, it checks the channel. As soon as the channel becomes free, say suppose station A as well as station B, both of them are having some frames ready with them to transmit through over the channel. Okay. Now what happens when it finds that the channel is idle? Okay. Station A, say suppose with the probability P, say suppose there is if I take 3, probability as 0.3, and let this be the probability as 0.7. Okay. So there is a 30% chance that the station A would transmit that frame through this channel. Whereas to transmit the frame through this channel, there is a 70% chance to transmit the frame by the station B onto this channel. Okay. So now again, either it 30% chance, either it may send or it may defer or it may postpone for the next time slot. Again, it will sense the channel. Again, either it may transmit or it may not transmit. Say suppose if the probability is 0.5. So there are 50% chance either station A would transmit or 50% chance that either station B would transmit through this channel. Is this thing clear, everyone? Hello? Is this thing clear? How about others? Okay, so this is about the CSMA. Now, if I go through the performance of this CSMA with this pure aloha, slotted aloha, you might have observed this is the performance of this pure. This is a throughput. Okay, you can see that at the lower value of this attempts per packet time, you can see that the non-persistent CSMA, here this is the non-persistent CSMA, this graph. Okay, whereas you can see that one persistent CSMA is at the lower load, one persistent CSMA would work in more better way. You can see here, this is having the higher value than that of the non-persistent CSMA. Why this non-persistent CSMA is having the lower value than that of one persistent CSMA? Any one of you? Hello? Yes, due to the wastage of the bandwidth. Okay, so non-persistent CSMA, if the load is less, then there would be a wastage of bandwidth, and hence you can see that it is having the lesser value than that of this one persistent CSMA. Whereas you can see this is 0.5 persistent CSMA, P persistent CSMA. You can see that in case if the load is less, okay, this would be more better. And as the load increases, you can see that if say suppose there are number of stations which are ready to transmit at the same time, so as this p value decreases, you can see that the performance would be increased. You can see here, okay, 0.1 persistent CSMA means what? There is a 10% chance with either to transmit a frame or it has to differ. Okay, again here it is 50% chance to transmit a frame or to differ for the next slot. Okay, so this is how this is about the comparison of the various CSMA algorithms. Okay, so next is CSMA with collision detection. So here we have seen that as soon as the frame is ready, as soon as it would start transmitting, provided the channel is free. Okay. Now, if more than one station starts transmitting at the same time, there would be a collision. Fine. If there is a collision, there is no point in transmitting the entire frame. Are you getting this? Either the first bit is collided or the last bit is collided. It doesn't matter. There is no point in transmitting the entire frame provided if there is a collision. Are you getting this? So as soon as the collision is detected, the station has to stop transmitting further that particular frame. Are you getting my point? Hello. If a collision is there, so suppose 10th bit it has transmitted, and meanwhile B has also transmitted. Okay. Now, still this is transmitting and there is a collision somewhere in between. Okay. So is there a point to transmit the entire frame even if there is a collision? Yes or no? There is. So as soon as the collision has occurred, there is no point in transmitting further the entire frame. Just stop transmitting further, isn't it? So that is nothing but CSMA with CD. So as soon as the collision is detected, CD stands for collision detection. So the station has to, while it is transmitting, at the same time, it also has to listen to the channel. Okay. So if it finds that there is a collision, it has to abort transmitting the frame further. So for example, say suppose this is the frame which is transmitted. Now this is some idle period, and say suppose station A as well as station B, both of them have started transmitting, and once it finds that there is a collision, it would not transmit the entire frame, but it would stop there itself so that the bandwidth can be saved. Are you getting me? Okay. So you can see that that's why you are having this contention period. So in this period, it has found that there is the collision has occurred and they have stopped transmitting the frame further. Okay. Similarly here, after some random period of time, it might have again sensed, and one of the station is now having certain frame and they can transmit the frame further. Okay. Again, you may find some contention slots here. This is due to the collision. Only few number of bits might have been transmitted, and the rest of them, since it has collided, it has stopped transmitting further. So like this, here you are having some idle period in which none of the station is trying to transmit the frame through the channel. Okay. So this is nothing but the CSMA with collision detection. Okay. Now, you can observe here. Say suppose this is my LAN and there are 4 stations A, B, C as well as D which are there onto this LAN. Okay. Assume that first station A is transmitting certain frame through this channel, and as we know that there would be certain propagation delay. So this is the time axis. This is T1. Meanwhile, still this frame has not reached to this host our station C. Okay. Meanwhile, see here, station C is receiving this frame which is sent by this A at time T3. Are you getting this? This is a time T3. Station A. C would sense it. It would take time T3 to reach the frame or first bit of the frame which is sent by A to the station C. Fine. Meanwhile, you can see that before that time, that is at time t2, at this time, uh, C may find that the channel is idle because this A has not reached to this C yet, because T3 is greater than T2. Okay, so what it finds that the channel is free, and it starts transmitting the frame through this particular channel. Okay, so what happens here at this here, somewhere in between, the A's frame as well as C's frame, both of them would collide. Okay, and the news of this collision would reach to this A at this time T4. Are you getting this? Hello. It has collided somewhere at this point. Okay. Hello. Hello. Actually, the power turned off in the lab. So I'm trying to join using mobile. I'm audible. Okay, fine. Just wait. Just a minute. The power has turned on. Let me once again start my system. Just a minute. It was very bit difficult for me to share the screen on this with this mobile. It was a bit difficult. So I'm trying to join once again through the system. I'll join once again through the system. Am I audible once again? Sorry for inconvenience as the power went off. Am I audible now? Okay. Okay. So, we were discussing about this, isn't it? So somewhere here, say suppose the collision has occurred. Is the screen visible? Wait, let me share the screen. I forgot to share the screen. Okay. Okay. So at this time, at this instant, the collision has occurred, but to make out whether the collision has occurred, it will take this much amount of time, T4 time. Are you getting this? A has detected collision at T4, isn't it? Similarly, C has detected the collision at this instant, that is at T3. Fine. So now, in case say suppose A has already finished transmission of the entire frame. Okay. The entire frame has already been finished, and A has finished its channel. Okay. Before this T4. So what it will assume that uh, when it senses the channel, it will find that some collision has occurred, but it would not make out that this collision is due to the its own frame. Are you getting this? Hello? Hello? Am I audible? I don't know what, there is some issue with today's network as well as the power supply. Uh, In case, if say suppose the entire frame has been A has already finished transmission before it senses this the collision. So what happens? What it assumes that the collision is not due to its due to it. It will not come to know that the collision is due to the frame which it has transmitted. It may assume that it might be some other two frames have been collided. Are you getting me? Okay. So A has to continue transmission of a frame till twice the propagation time, because say suppose the worst case what it would be, uh, A might have sent the frame to this D till it reaches to this other end, and when the if a collision is detected, the other it might be possible that again it may take the other TP, that is a propagation time, to sense the collision. Okay, so that means A will come to know that it has seized or it has got hold of this channel only at the end of twice the propagation time. Is this thing clear? Say A is transmitting a frame, okay, and assume that it has reached to D, and the first just before reaching to D, there is some collision has been occurred. Assume that some collision has occurred, and again uh, after once the collision has occurred, that would be reflected and it would be read by this station A. So again, it would take the propagation time TP to reach this collided message to this station A. Are you getting me? So that means approximately up to equal to twice of propagation time. It at this instant of time, it would come to know that it has it after this it may come to know that it has seized this particular channel, and it may start transmitting through that. But it implies that it has transmitted the frame without any collision. Is this thing clear, everyone? So you can see that A has sent from T1 to T4. Meanwhile, C has sent only up to this much frame it has sent, and you can see that there would be a collision. Okay. So C detects collision here, whereas A detects collision here. So what if, say, suppose the entire frame has already been sent before it detects the collision, A would assume that this collision might be due to some other station, not because of its own frame. Okay. Hope this is clear. So it has to continue transmission of the frame till the twice of the propagation time. So the frame size should be such that the it should be such that up to twice of the propagation time it would continuously, it has to transmit the frame. Fine. So this can be illustrated with an example. Say suppose a network using CSMA CD, it has a bandwidth of 10 megabits per second. Okay, the channel has a bandwidth of 10 megabits per second. If the maximum propagation time, including the delays in the devices, etc., is 25.6 microsecond. Propagation time means what? From to reach from A to the farthest station, which is at D. So this much time is nothing but the propagation time, and it takes around 25.6 microsecond to reach a single bit to that particular station. So what should be the minimum frame size? Okay, what should be the minimum frame size, so that even if after as we know that it should be twice of the propagation time. Okay, the frame size should be such that the minimum size should be such that it should be twice of the propagation time. So we have to find out what can be the minimum frame size. So as we know that the frame transmission time is equal to twice, as I said that it should be twice of propagation time, and it is given that the propagation time is 25.6 microsecond. So multiplied by 2, it would be 51.2 microsecond. That means I have to choose the size of the frame such that up to 51.2 microsecond, it would continuously transmit the frame. Okay. This means in the worst case, a station needs to transmit for a period of 51.2 microsecond to detect the collision. Okay. So and since we are having the channel of 10 megabits per second, and the propagation time is 51.2 microsecond, and if I multiply with this, what it comes to be, it is approximately, it is equal to 512 bits. Okay, 10 into 10 raised to 6 bits per second multiplied by 51.2 into 10 raised to minus 6. So this would be equal to 512 bits. So that means my frame size, this is the minimum frame size, not the maximum can be of maximum size can be anything, but the minimum frame size should be of 512 bits, or that is 64 bytes. Okay, that means if I'm having the frame size of 64 bytes, that frame would reach to the other end, and it's and once again it would be reflected back, and it can sense whether it has received the the up to the twice of the propagation delay. It would make out that whether the frame has been transmitted successfully or it has been collided. Is this thing clear, everyone? Why this is twice the propagation delay? So you have to continuously send the frame up to the frame size should be up to 512 bits. Then only it would be a successful transmission. And that should be for 51.2 microsecond. Okay. Hope this is clear, everyone. Hello. Shall I repeat this thing? Why it should it be? Say suppose if I'm having the frame size of 200 bytes, 200 bits. So what happens? Before it reaches to the other end, it has fully, the A has fully transmitted that frame to the other end. Are you getting me? Hello? The frame has fully transmitted the frame because it is of only 200 bits. Okay. Now, before reaching the acknowledgement, it has already transmitted the entire frame. So if it senses the channel later, it would make out that there is some collision, but it would not make out that it is due to the frame whose size is 200 bits. Okay. Whereas if I use 512 bits, this is the minimum size. It can be greater than that. It can be greater than that. So if this station A is transmitting and again it is listening to the channel, so still it is transmitting, still that frame is not finished transmission, and hence it can make out that there is some collision. Are you getting this, all of you? Okay. So how to make out whether there is a collision or not? So if say suppose the signal is having some strength, okay, so that means uh, some energy, some limited energy is there. And if the channel finds that some limited energy is onto the channel, that means there is some frame, some frame, valid frame has been transmitted. In case if a collision has occurred, say suppose station A is also sending, station B is also sending, and both the frames would collide. In that case, what happens? The strength of the signal would be increased. Okay, you can see that this is my energy if a valid frame is sent without any collision, whereas here you can see that this energy level has been increased. If any host wants to send certain wants to transmit, first it would sense the channel, and if it finds that the energy level is very high, it implies that there is a collision and it would stop transmitting the frame further. Is this thing clear, everyone? And if there is no signal, it implies that the channel is idle. Hope this is clear, everyone. Okay. So this was about the CSMA CD, and usually that is used for the local area network, and that too for the wired network. Okay. Now, in case of wireless network, we cannot use the CSMA CD because in case of wireless network, what happens? The strength of the signal would be it would be deteriorated or it would be lost. Okay, in case of wireless network. So even if it sends some frame, and if say suppose station B has also sent certain frame, but if that station A once again listens to its own data, so to its own frame, but due to some atmospheric pressure, atmospheric noise, or due to some the signal would not be received with the same strength as what the A has transmitted. Okay, and if say suppose meanwhile B has also transmitted, there would be very less variation of the signal, even if there is a collision. As in case of a wired network, you can see that the energy level of this collided signal would be too high. But in case of wireless network, even the collided signal would not be that much high, so it may not come to know that it is due to the collision or its own signal. So that's why CSMA CD cannot be used for the wireless network. So for that, there is one more approach which is known as a CSMA CA, that is carrier sense multiple access with collision avoidance. That this indicates. So it tries to avoid the collision as far as possible. Okay, that is nothing but the collision avoidance. Hope everyone is clear up to this, why we cannot use CSMA CD for the wireless type of network, because the signal strength would be very less, and even if the station receives it, it may not be able to make out whether it is its own signal, means whether it is a valid signal or it is a collided signal. Okay. So in case of CSMA CA, the station who wants to transmit, they continuously sense the channel. Okay. If it finds once the channel becomes free, there is some space. What happens, isn't it, in CSMA, one persistent CSMA, what happens if more than one channel finds it idle? Both of them starts transmitting and both of them would collide. Okay, instead what it will do, it would once if it finds the channel as idle, there is some interframe space, which is also, this is known as an interframe space. It would not start, the station would not start transmission as soon as the channel becomes idle, but it will wait for certain period, which is known as an interframe space. Okay, it would wait for certain period, which is known as an interframe space. Assuming that some other station might be, they might be willing to for the transmission. So it would just sense whether there is some other station is started transmission or not. For that, it's for this much amount of time, that is interframe space, it would just wait. Okay. Now after interframe space, again it would not start transmitting immediately, but what it will do, it would check, now it would check, it would wait for this contention window. Here what happens, now if it the contention window is ranging from 0 to 2 raised to k minus 1. Okay, for the first time, and it uses this binary back of algorithm, binary back of exponential algorithm. Okay, that means what? First time it would have k would be 0. So 2 raised to 0 is equal to 1. 1 minus 1 would be 0. Okay, that means after interframe space, immediately it would start transmitting. Now what happens? Some other station, if even it has started transmitting here, what it will do? There would be a collision. If there is a collision, then k value would be incremented by 1. Okay, so now it would be 2 raised to 1 minus 1. So now there are two slots, either slot 0 or slot 1. Okay, so as the number of collision increases, the k value would increases, and now every time it would be multiplied by 2. So 0, 1, now the next time it would be 2, 3, up to 3. So there would be 4 slots, and among this randomly it may choose one of this slots, say suppose slot number 2. So after interframe space, it would wait for slot number 0, slot number 1, then at slot number 2, it would start transmitting the frame. Okay, so now every station would, based upon the number of collisions what they have faced, the k value would be changing. Okay, so it is less, as the k value increases, the number of slots increases, and any a station has to choose any one of the number from this particular given contention window. Followed? So if the number of slots are more, the possibility of collision would be less, because various random numbers would be there, and they choose different random number, and hence more number of stations would not start transmitting at the same slot. There is a less probability of transmission during of choosing the same number by more than one station. Okay, in case if, say suppose at every slot, if it finds, say suppose at slot number 0, slot number 1, now say the station has chosen this slot number 2. Now at once it has sensed this slot number 0, it is waiting. At the end of this slot, it would check whether the channel is free. If the channel is free, nothing to do. Again, it would check for the next slot, that is slot number 1, check whether the channel is free. If the channel is not free, and if someone else has already successfully started transmission of the channel, transmitting of the frame, what it will do? Now it has to, actually it was its own turn, but some other station has already, they have used this slot number 1 and they might have started transmitting the frame, isn't it? So what happens? This particular station, now what it will do? It will stop its timer. It will stop its timer. The other station, say station number B, which has already started transmitting at the slot number 1. What it will do? Again, it is transmitting. Then it has to wait for this interframe space, and then now once it has finished this interframe space, now it once again it would start the timer. Now it is its own turn, so it would start transmitting the frame through the channel. Is this thing clear, everyone? Okay. So in this sense, it is using the collision avoidance. Okay. Apart from this contention window, it also uses the acknowledgement, positive acknowledgement. Okay. So the receiver has to provide the acknowledgement to the sender saying that it has received the frame without any collision or without any error. Fine. As well as, say suppose if the sender does not receive any of the acknowledgement, what it will do? It would time out, and once again you can see that it times out, and if the acknowledgement has not been received during this period, then once again it would again perform these operations. Hope everyone is clear with this, or shall I brief these things once again? Hello. Okay. See, collision CSMA-CD is clear, and why we can't use CSMA-CD for CSMA-CA. Is this thing clear? CSMA-CD has the low propagation delay. It can be used only for the uh, wired networks where it can sense or it can read whatever it has transmitted. By looking at this, it can make out whether the collision has occurred or it has deferred, or the collision has not occurred. Whereas in case of CSMA-CA, due to the uh, the energy of the frame would be reduced as it is sent. So even if there is a collision, there would be a very less increase in the energy, and hence it may not be able to know whether this change in the energy is due to the collision or it is a valid frame. Is this thing clear, everyone? So to overcome this, we are using CSMA-CA, in which the channel is continuously sensed. Now, if in case if the channel is found idle, at the same time, the stations may not start transmitting. It has to wait for the interframe space. So, interframe space. See, all the stations may have different amount, different value, different interframe space. Some may be less, some might be more. Okay, the one which is having less interframe space, that means it is having more priority. Are you getting this? Because it is having more chance to start the transmission of the frame through the channel. Is this thing clear? This interframe space is meant for each of the station differently. Okay, all of them are not having the same amount of interframe space. Some might be less, some might be having more. Okay, the one which is having lesser value of interframe space, it is having more priority, and it is given more chance to send the frame as soon as the channel becomes idle. Is this thing clear, everyone? Now, after this interframe space, there would be a contention window which uses this binary backoff or binary exponential backoff algorithm. Say suppose after the interframe space, so one of the station wants to send the data through the channel at slot number 0. In case if the slot number 0 is there, and if there is a collision, some other host or might also have used the slot number 0, and meanwhile both of them if starts transmitting at the same time, there would be a collision. Okay, so what happens if there is a collision? The k value would be incremented, and now there are two slots, 0 as well as 1. Okay, once again if there is a collision, again k value would be incremented. Now there are 4 slots, 0, 1, 2 as well as 3. 0 to 2 raised to k minus 1. Is this thing clear, everyone? Okay. So in case now the station can choose any of the slot number from this contention window, and this is random number. Okay, any random number from this 0, 1, 2, 3 it can choose. And say suppose if it has chosen slot number 2, okay, and meanwhile at slot number 1 some other station has successfully used this channel, and if it is transmitting, then the timer of this host who is using the slot number 2, it would be stopped. The successful transmission of some other station has been finished. Its interframe space time is also finished. Then comes the slot number 0, 1, 2. Now the turn again it would start the timer, and when its turn comes, it would start transmitting the frame through this through the channel. Apart from that, it also provides the acknowledgement. Okay, the CSMA-CA uses this acknowledgement to indicate whether the frame has been received correctly or not. So either the receiver has to send the positive acknowledgement, or in case if the acknowledgement has not received by the sender, then it would time out and it would retransmit the frame once again using the same procedure what we have discussed. Is this thing clear? So here it says in CSMA-CA, the IFS, as I said, if the IFS is small, the station which is having the interframe space small, it is having more priority. Okay, fine. Then if the station finds the channel busy, it does not restart. That's what I said. If some other station has already used, it has started the transmission of frame, it does not restart the timer of the contention. It stops the timer and restarts it when the channel becomes idle. Okay. So this is about CSMA, CSMA CD, CSMA CA, and this is used for the wireless networks. Okay, so we till the CSMA CA it would be there in your course for your sessional. So wishing you good luck for your exams.